And welcome everybody. I hope to make this worth your while. Um, let us delve right in. Today is, of course, the first official day of the Atlantic hurricane season. We have had two named storms to date, although one can question the naming of I think what was it, Bonnie, the one we just had. And there's even the possibility that we could see Colin, although that's far from assured. There are some signals that we could get another at least attempt at something resembling a tropical cyclone, perhaps in a few days over the Caribbean, and then quickly moving north in the general direction of Florida. But we'll just have to see. Quickly, the way that this presentation will go is we'll talk about some important factors for hurricane development. I think most people on this call have probably seen these at least briefly in other forums. We'll look at the differences between active versus inactive years, and we'll try to put 2016 in context of that comparison. Some factors that influence Atlantic hurricane development. This is by no means a complete list. And again, a lot of these are things that have to be monitored for in the season, but these are meteorological factors that are known to strongly modulate the frequency with which hurricanes develop and the intensity of the storms. The state of the El Nino Southern Oscillation phenomena, which we'll touch on briefly. I think, again, as most people on this call are aware, we are coming out of a pretty robust event. Did have significant differences from previous, well, there haven't been that many other strong El Nino events in our limited sample, but it did have marked differences. It exhibited very significant differences even from the most recent strong El Nino event, which was in 97, 98. Sea surface temperatures, of course, we know that there's a general threshold. Generally, about for really intense storms, you want to see sea surface temperatures above about 29 degrees centigrade to get really intense storms. And for storms that develop in the deep tropics, at least 26 to 27 degrees C, or about 80 Fahrenheit. That's important, and there's a lot of sensitivity there, which again we'll touch on. Even a degree centigrade makes a pretty significant difference in the potential upside for a storm in terms of how strong it can get. The strength and eastward extent of the North Atlantic summertime jet stream, that's not something you usually hear people talking about. But observations over the years have borne out the idea that during summers where a lot of other factors seem to be in the right place and the right phase for a big season, we've seen recently, even as recent as some of the last couple of years, seasons get short-circuited and the potential suppressed. And a big part of that is because we get a lot of activity in the jet stream. Again, we'll touch on that can suppress Atlantic hurricane formation, and this factor is not predictable until you're in the season in general. A few of these other factors here, everyone knows about vertical wind shear. If you don't maintain an environment where a developing storm can remain upright and free from dry air entrainment, then it can't get going. Moisture, which really, again, is related to the points 4 and 5. Atmospheric stability is just basically how much energy is available for the thunderstorms that develop into these systems, how much energy is available for those storms to grow. Saharan dust, again, that may be tied to some of these others, and there's just so many factors to list that it just, you can get lost in this laundry list of items. So moving on. The first thing to talk about is that there may be a subseasonal signal emerging, meaning a process that's occurring on time scales that are shorter than the season itself. And we're monitoring for that. My colleague here, Ed Berry, he is pretty well known for having helped develop a framework for monitoring activity, particularly on time scales that essentially range between roughly a week into the future and about 60 days, give or take. Again, a very loose, there's no thresholds in the atmosphere ocean system. Those are things we impose. But again, a general range of time and space scales that cover the range from 7 days into the future to about 2 months in the future. We have a behavior that likes to evolve on those time scales that's apparent to us when we do a quick analysis of things like winds and satellite imagery, and we've put together this composite, this annotated satellite picture here for you today to show one of the things that we're watching that may well influence the tropics on the Atlantic side, not only over the coming next couple of weeks, but possibly for the balance of the season. And briefly, what we have here is, again, a remnant of El Nino itself. We've got an enhanced belt of convective activity. Again, that's just stronger than normal thunderstorm activity over the very warm waters of the tropical eastern Pacific, annotated here. This is part of what's called the intertropical convergence zone, again, a term that many of you may be familiar with. It's just basically an area in the tropics where the trades they come together at the surface and help to foment the development of enhanced thunderstorm activity. That's very agitated right now. And that's part of an overall disturbance that's slowly moving east. And if this continues to evolve eastward in the coming weeks, this could set the stage for a more active season than we've been kind of preliminarily expecting. And we don't know that will actually occur. All we can do is monitor this type of signal over the rest of the season and see whether in fact this area, this envelope of disturbed weather is very gradually making its way east. So that's something we've got to watch for. And even if part of it moves quickly east, some portion of it could linger over the western Atlantic where the waters are quite warm and possibly increase the risk closer to home. And we just have to monitor for that. There's no way to say for sure whether in fact this will occur or contrary to that, whether this signal just sits out here in the eastern Pacific, which if it did, could have a suppressive effect on tropical cyclone activity in the Atlantic side. Moving on, so let's look at some of these factors. Sea surface temperatures, compositing on the most active years in the recent era, meaning about the last 20 years. Not surprisingly, going into that season, April to June, you tend to see very warm sea surface temperatures with departures of at least 1.5 degrees Fahrenheit or a little over a half to a degree centigrade right here over the what's called the main development region, which I've annotated in a box. This year, at least through the latest data point, which is at the time of I'll say the freshening of these slides, if you will, was May 29th, April 1st to May 29th, so pretty much all of April and May, you can see sort of a hole here where it's not quite as warm versus the composite. In fact, if you look off the coast of Africa, we've got processes tied to the extratropics in addition to some enhanced trade winds that are resulting in a cooler than normal situation there. And that actually may have a tendency to, if anything, spread westward over time. We'll just have to watch it. If that does occur, that could help to create less favorable sea surface temperature conditions in the east central Atlantic. However, for now at least, what you can see is that in terms of departures from climatology, the waters are very much above normal over much of the Caribbean and the western Atlantic basin. If that were to persist, that would be favorable. Moving on to looking at, so how about El Nino Southern Oscillation? We do have a situation where we've got a decaying El Nino. It's going to take some time, we think, for the atmosphere ocean system to trend all the way to a La Nina state. But in those summers where La Nina exists, in general, what happens is you tend to get a lot of tracks, a lot of activity in the Atlantic. In fact, it might be helpful to compare this to the tracks now these are major hurricanes, I should mention. Well, all that was done here was to look at major hurricane tracks during La Nina summers and compare those to El Nino summers in the Atlantic Basin only. And what you notice is a far lower frequency of major tropical cyclone tracks during El Nino summers versus La Nina summers, and that's really the main takeaway. There are some apparent variances in the tracks, but that's really pretty much noise, especially given the limited number of samples in the El Nino summers. The key takeaway is that we are trending to La Nina this summer, and if atmospheric behaviors become more consistent with that, that would be a favorable factor, at least for numbers. Moving on, a factor that I mentioned earlier that we don't have a good handle on going into the season is how much North Atlantic jet stream activity we get. It turns out there was a study recently published that kind of formally revealed what those of us in the business have known or suspected at least all along, just based on experience and watching this stuff over time. And that is that when you have a strong North Atlantic jet stream, one in which you get a lot of eddies that are embedded in that jet stream tend to get elongated northeast southwest, because the northern portion of those eddies, they're just basically like high and low pressure systems embedded within the North Atlantic jet. When the northern portions outrun the southern portions tend to get stuck back in the western Atlantic, and they can have a shearing influence on storms. They can transport dry air southwestward from sub-Saharan Africa and even from the European mainland back into the tropical Atlantic and lead to suppression of Atlantic activity. And this does seem to be a significant factor. But in order to predict whether that will actually stymie development within a given period, you have to actually get to that period to be able to tell that. There may be some hope to develop diagnostics that can help us going into the season, but they really don't exist yet. So that's something we're going to have to watch. That's an unknown. Looking again at the active years minus, so I took about 5 of the most active years in the current era, and I subtracted from that the least active years in about the same era. You'll notice my earliest year for the actives is 95, and my earliest year for the inactives, which was going into a pretty strong El Nino, was 1997. And so what are those? When you do that differencing, you get a pattern of a difference pattern that kind of shows you what a favorable environment looks like in terms of the large-scale winds. So these are basically how much stronger. Let's just look here over South America and the Atlantic. See these winds blowing from east to west at high levels of the atmosphere. This is part of an enhanced active easterly Atlantic jet. This is an active easterly jet coming off of Africa. And you tend to see that in these active seasons. You get a lot of storm activity that develops over Africa that then gets entrained within that easterly current, moves across the Atlantic, and then these can develop as they approach the mainland. Also notice that the wind patterns tend to come together or converge over the eastern Pacific. And so over that part of the tropics, you tend to see a suppression of activity. Finally, notice that related to the East African jet, you have winds blowing from the Indian Ocean back over Africa, so they're blowing towards the west, and then over the Indonesia area, winds blowing towards the east. And so here's an area where winds at high levels are blowing apart. They're diverging, so air underneath is often rising, and that's favorable for storm activity. So one way of looking at this is the most active seasons tend to go hand in hand with an active Southeast Asian monsoon, a suppressed Eastern Pacific storm regime, and an enhanced upper-level easterly jet. So with that in mind, where do we stand this year? Again, it's early. All we can do is look at data. That was July to September. We're trying to figure out, we're trying to see how we stack up looking at April and May only, and that's tough to do because things can change a lot. Well, toggling back and forth, at least through the current time, we've almost got the opposite situation. We've got westerly winds aloft over the tropical and subtropical Atlantic. Again, going back to our favorable composite, which is really what this is. we don't have the easterlies that we typically see during the most active years. We've got westerlies. Now, these have been weakening over time, and if you recall back a few slides ago where I discussed the subseasonal process that we're watching, that could change very rapidly. So that's something, this to me really jumps out, that right now we still have a lot of westerly wind flow, and we've really got to do work to reverse this situation. Likewise, instead of having winds converging aloft over the East Pacific, again, go back to the favorable Atlantic composite, winds are actually converging, which is favorable for suppression of storms in the East Pacific. We have the opposite right now. So this is not necessarily a positive factor for a hyperactive Atlantic season, but it can change. So given all of those mixed signals, what's the forecast for 2016? Well, as you might suspect, given that we have a number of conflicting factors right now, lacking any additional information other than the fact that we do have a subseasonal process that, if it continues to evolve east, could swing this forecast a little higher. Right now, the correct forecast is still climatology. And on average, what does that mean? It means 12 named storms, give or take a couple, 6 hurricanes, give or take a couple, including 2 to 3 major. Again, current prediction schemes can't account for all of the factors that we know are important for modulating frequency and intensity. Also, I'd remind people that hybrid systems like Sandy have very little predictability. It only takes one storm like a Sandy or an Andrew. If you go back to 1992, which was not an active season, Andrew was the first storm of the season, and it was a doozy. It walloped South Florida and then went on to hit Louisiana very hard. So for those folks, that was an active season, even though the numbers didn't make. Given the climatology forecast, what can we say, if anything, about specific threats to specific portions of the coastline? This is an exercise where, looking at the history of hurricane landfalls, one computes the average, what's known as return period. Now, one has to use these statistics very carefully, especially in an era of changing climate. For example, we've had no major landfalls in about the last 10 years. So, the real statistics may be changing very quickly. But given what we have, the return rate is lowest, meaning the threat in general, looking at the whole history, is greatest for the areas you see in red. Not terribly surprising for either South Florida or the Outer Banks, because they're kind of exposed, they stick out there. Likewise, you see some areas in light green, like along the South Texas coast, and interestingly, western Louisiana, where the return rates are higher, meaning you might have to wait longer for a significant storm. That's an interesting and somewhat useful piece of information if you're doing long-term planning. But again, any one year, it can be year to year on a given part of the coastline with little predictability. Likewise, for numbers, I think everybody's familiar with this chart. The peak of the hurricane season, it's more or less sharply defined around early to mid-September, but with a gradual tail into October. In fact, there's evidence of a secondary peak in October, which is mainly focused on the Northwest Caribbean, where it stays very warm. So that is all I have, and now I will pass it on to Mike.
Thanks, Dave. What I want to do at this moment is just take a few minutes to communicate how WDT provides our information, communicates the risk to our clients during the hurricane season, which is just as equally important. You need to know really where the storm is, where it's going, how intense, before you can start making your decisions. So we do this on we call it a forecast funnel approach, where at the top of the funnel is usually our general information, the broad information about the system. Then we kind of drill down or funnel down into more specific information that could be specific to an asset, to a location, or to whatever operation you have going. So it's just a couple of slides where I'm going to show the various parts of information that we provide to our clients. And okay, there we go. One of the, let me go back, I hit it too fast. A lot of our forecasts and our information is customizable to client operations. So one of the first things that you'll see that we've already started issuing is what we call our Tropical Daily Planner. This information is issued daily during tropical season. And what we do is we pretty much look over the entire basin, tropical Atlantic basin, suspicious areas of development, and then we put a probability on any of those areas of disturbed weather, and we track them through various means of maps, forecast models, and discussions. We extend this outlook to 7 days. Essentially what it does is we put a probability of development on the system and then the likelihood that it could affect a particular area like the Gulf of Mexico or the East Coast of the U.S. So our Tropical Daily Planner is kind of the first means of providing that information. And during, it's issued once daily, but when we get into the busy part of the hurricane season, which is usually around August and September, we will issue that update twice daily, especially if there are any active systems that we're monitoring. Another piece of information that we provide is what we call our active storm advisory. So whenever a system does develop, first a depression or to a tropical storm or a hurricane, then we issue a specific storm advisory that highlights the storm, its attributes, typical information, location, intensity, max winds, and movement. And we issue this every 6 hours, and the track is issued for 5 days. And the meteorologist will also go in there and provide some discussion, especially what the effects offshore will be, and also any effects onshore. So we're really looking at any threat to offshore environments as well as to the immediate coast. And the active storm advisory is issued to provide all that information when we do have an active storm. When we do have to issue some alerts that are specific to a customer's asset or location, we'll do these short fuse type of updates that convey either National Weather Service information, such as storm surge information, or let's say even like a tornado watch when there is a hurricane approaching the coast that many times does spawn off tornadoes. So what we do is we issue these kind of local centralized alerts based on changes that might only occur in a small area, and these could be the strong winds, lightning, the heavy rain. So we'll augment our advisories, our active storm advisories, with these individual alerts. As we drill down further into the funnel, we have developed some really nice guidance tools that allow the operator to base some decisions on, just how far that storm is and what the effects will be at their location. One of these is, we call it the Tea Time Report, and it was really designed for an offshore asset, but actually used both onshore and offshore. And how it works is you have an asset, let's say it's a rig and it's offshore, and you know that to secure that rig takes X amount of hours before you have to get off that rig. That tea time, which is the amount of hours to prepare and shut down, we actually plug that into a formula, and then we can calculate based on the forward motion of the storm, the speed of the storm, we can calculate a date and time of where you need to make that decision to start the shutdown process. And we actually present kind of two scenarios. There is the forecast track scenario, which is based on the actual forecast. So let's say that might be 60 hours before you need to make the decision. But we also do a kind of a direct path or a straight line where the storm is moving from its location directly to your asset, kind of the worst case scenario. And then that number might be lower. But by providing these two numbers, it does give you some indication of when, the date and the time, when you might have to make that decision to shut down. So again, these This is a tool that's offered both offshore and can also be used onshore if you have that type of need. And then further, if your hurricane plans include certain actions that you need to take, we also provide this, we call it the risk and response plan, where, for example, if you've got to initiate actions when storm winds reach a certain level, or the probability of a particular wind speed will be this, then you initiate that action. We can actually integrate those actions into the storm report, which then kind of gives you a seamless planning tool of when you need to initiate those plans or those actions based on a change in the storm's either track or intensity. So all this, as you see with the funnel, this is really the drill down focused on each asset based on your plan. So really the main point of this part of the conversation is you really need to have a hurricane plan, storm plan in place prior to the season. I'm sure many of you have those plans, and what we're trying to do is provide some finer detailed tools to help you make those decisions. We are 24/7 operations. Our meteorologists are available at any time to take your calls, and you can even schedule conference calls if you need, so you can get a lot of people in, and they will be more than happy to assist you with any of the questions. So that's our services pretty much in a nutshell for the hurricane season. Hopefully, knock on wood, we won't be utilizing these services too much, but it is summer and hurricane season, you never know. If you've got any questions about our services, feel free to reach out to WDT or to myself, and we'll be more than happy to answer them. But that pretty much wraps up our presentation for today. Again, I want to thank you for joining us on this first day of the hurricane season.